All right, here we go. Hello, everybody. My name is Matteo. I'm a developer here in ThoughtWorks Italy. And before passing the mic to Steve, I'm just going to spend a couple of slides talking about what ShareIT is and the code of conduct for tonight. All right. I hope you see the presentation. And very quickly, ShareIT is a series of events powered by ThoughtWorks. ThoughtWorks is a global consultancy firm with offices across all the world, and specifically in Italy, we're based in Milan. In ThoughtWorks, we do put a lot of emphasis on learning, but also on teaching. That's why you might have heard ThoughtWorks as a company, because many of us publish several books throughout the years. And specifically regarding ShareIT, it is an Italian community whose goal is to share the things that we see, that we observe, but also that we learn every day at work in ThoughtWorks, and not just from ThoughtWorks Italy. That's why also Steve is here. So we take also the contribution and the experience from all the offices across the world. We usually talk about tech, but sometimes we also talk about other topics which are very dear to ThoughtWorks, like, for instance, diversity and inclusion. The code of conduct for tonight is very simple. So in general, let's just be kind to each other. And also keep in mind that different people might be at a different step of the journey about the topic of tonight. So keep this in mind when you interact with other people, especially with the vocabulary that you use, so that we can learn from each other and there are no barriers in learning from each other's experiences. In terms of mechanics, if you want to ask any question to Steve, there is a button down below with Q&A, so you can ask all your questions there. The expectation is that we're going to tackle these questions at the very end of the talk, and there's going to be pretty much a lot of time for it, so don't worry, but feel free to ask them wherever you want. Either me or Ronnie or Emil, who are the other two colleagues in ThoughtWorks Italy, will help me out collecting the questions, so just ask them, and then we're going to tackle them at the end of the presentation. Again, right below, but slightly more on the left, there is another icon, which is the chat one. So use that instead if you want to share any experience, any feedback, any story that you might have on your personal experience at work or also outside. So again, we can learn from the words of Steve, but also we can learn from each other. So if it's cool, Steve, I'll give you the mic to you. And yeah, good luck.
Steve, you're on mute. We cannot hear you.
Amazing. My first technical screw up of the day. Okay. So thank you for that lovely introduction, Matteo. That was very, very well organized. I am now going to try to share my screen. I'm going to have to move some things around. I think I managed to lose everyone's faces. Give me just a second here. There we go. Okay. So I assume you can all see my screen. And as mentioned by Matteo, I'm Steve. I'm a thought worker. I've been working at ThoughtWorks for about 4 years now. I am not based in Italy. I'm actually based in Berlin. So at least luckily on the same time zone. And I'm a QA, right? I've had most job titles at one time or another. Being a developer, I've been a developer advocate, a trainer, a data engineer, but officially I'm a QA. And the last couple of years, I've been working with a lot of big data projects. So I've been working with a lot of data engineering, data pipelines. I've actually spent almost 2 years now working on a huge data mesh transformation. And because I'm someone with the word quality in my job title, and I've been working in the data space, lots of people come to me with questions about data quality. Now, this question is like, what is data quality? Like, how do we measure data quality? How do we improve it? How do we work with this? There seems to be something I've noticed is that there's a lot of confusion around data quality, a lot of open questions, and I think one of the reasons for that is this here. See, we've all seen something like this. We've gone to a website, we've opened an app, we've tried to use a service, and we get an error, right? We see an error, and we obviously can't use the service we're trying to use. Anyone can look at this and say, there is a problem with this website. There is some sort of quality issue. And obviously, there's more to quality than just not having big errors. But we can look at this on some level and just say, yeah, there's a problem here. There's a quality issue here. there's a functional requirement that isn't being met, right? If I go to an online store and I try to buy something and I can't buy it, that's a functional failure. That is a quality problem. And that isn't always true when we're looking at data. Is there a quality problem with this data? What is the quality problem with this data? How could we improve this data? Where are the issues? This isn't so clear. And I've read a lot. I've spent ages digging into data quality, and there's lots and lots of articles and frameworks and tools to help you work with data quality. Here's a data quality management process for you. There's lots and lots of answers out there, but I still see this confusion. And my measured opinion is that despite all of these questions and despite all of this, really genuine confusion, I kind of think everyone's overthinking data quality. But I don't want to jump right into this. I don't want to just say, hey, here's how you're misunderstanding things. I actually want to be honest and say, look, when we're working with data and data quality and testing in the context of data, yeah, there are some things here that are kind of difficult, honestly. I don't want to shy away from this. So I want to focus on the things that are actually difficult first. And the first of those big challenges when we're talking about and working with data quality is related to the Oracle problem. Now, I've got a chat here. Who here has heard of the Oracle problem? You could, if you want, you can put your messages in the chat, like who knows what the Oracle problem is. Just to be clear, this isn't about the software company Oracle. That's a different problem. But the Oracle problem is actually one of the oldest problems in software engineering. And it's related to these this lady here. So this is the Oracle at Delphi. And she was a mystical Greek lady who was locked in a temple. And there's already quite a lot to unpack there. But people, you see these people here, would go to the Oracle. They'd go to the Oracle in her temple and they would ask her questions. They'd ask her questions like, what is the weather going to be like next week? Or what's our harvest going to be like this year? Or if we go to war tomorrow, will we win? Because the Oracle had the power of foresight. They could see the future. They knew the correct answer to those questions. And if you're going to go to war tomorrow, it's quite useful to know whether or not you're going to win. That's quite a useful insight to have, hence having these oracles and going and asking them questions. But what does this have to do with software engineering? Well, it's related to this line of code here. And if you're in this webinar, I'm going to assume you've written or seen this line of code somewhere, right? We're saying this is part of a test. We are asserting that the actual result we get from the test is the same as the expected result. It's the same as what we expected to get. The problem here is, in order to know what we expect, in order to know the correct answer, we need an oracle. We call this a test oracle. We need a test oracle to tell us what the correct answer is. The problem is oracles aren't real. There aren't mystical Greek ladies we can just ask and they will always give us the correct answer. That's the oracle problem. We don't always know the correct answer. We don't always know what we expect. And sometimes this isn't a huge problem. So imagine you're writing a test for, say, a shopping cart, right? Some online store. I create a shopping cart. I add a test item to the shopping cart, and then I expect that the size of the cart, so the number of items in this shopping cart, is going to be equal to 1. This is fine, okay? If I add 1 item to the cart, there should be 1 item in it. That's simple enough. This is not a huge problem here. But what about this? What if I'm doing floating point maths? What if I'm multiplying 2 very big floating point numbers? What is the expected answer here? This is difficult because it depends. It depends on the software we're using, on the platform we're using, the library, the language, even the hardware underneath us that we're using will change the answer here. There's potentially a wide range of valid answers. They will have different precisions, different floating points, different mantisses, but they can all be valid answers. The problem is we don't know exactly what to expect. That's a problem. That's the Oracle problem here. Then we have things like this. What if we're training a machine learning model to predict the number of sales we're going to get next month? How many sales are we going to make next month? And we use this information to plan our stock, how many things we should buy and how much inventory we should hold. Okay, that's a pretty reasonable thing to do. That's something we do quite a lot of. Train a machine learning model to predict the future. But what is the expected number of sales? What is the correct number of sales for next month? If we knew the answer to that, we wouldn't need to train a model to predict it for us. The only way to know the correct answer is with an oracle. And again, they don't exist. That's the Oracle problem. The Oracle problem is one of the oldest problems in software engineering, but it's really front and center when we're talking, when we're working with data. Another interesting problem we get here is that often we process our data, we run our pipeline, and the actual output of that pipeline could be in the gigabytes, could be even in the terabytes. We're processing huge amounts of data. So that's a lot of data to compare. Computationally, it's not that hard, but it's a lot of work to really set all of that up, so we know exactly what to expect. So we have two key problems here when we're working with data, when we're trying to test data and validate that we are building the things that we expect to build. The first is we don't know what to expect all of the time. And the second is, even if we did know what to expect, the answer would be too big. So these are two distinct problems, and I want to deal with them one by one here. Okay, so the first one is, how do we deal with not knowing what to expect? The Oracle problem. We don't have a test Oracle. Well, I mentioned that the Oracle problem comes from this line of code here. All right. I'm asserting that what I get is what I expect to get, and I don't know what I expect to get. Well, this line of code here is an example of what we call example-based testing. We're running a test, and we are giving the computer an example of how the system should work, an example of correct functioning of the system. But there are other ways to write tests. This isn't the only way of writing tests. Another approach we can take is what's known as property-based testing. So with property-based testing, instead what we do is we generate a bunch of test inputs, lots and lots of potential things, potential inputs that we could put into our system, the thing that we're testing. And then we put it all into the system. So we run our test, we put all of these inputs into the system. And then what we do is we assert that every result we get has certain properties. So instead of comparing an expected and an actual, we're checking that whatever we get has certain properties. The answers should all have the right shape. So let's give an example here, right? Let's imagine we're testing the classic string.concat, right? So we're concatenating two strings. We've got two strings, we add them together. What I could do for this is I could generate lots of test inputs, right? Here are all of the things that I'm going to put into this function to test it. Okay, technically there's two arguments here, so there should be a list of two, but you understand how this works, right? Then what I do is I put all of those inputs into the test, into the system that I'm testing, and I assert properties about properties of the answer. So I might say, whatever I get out of this function, it should be a string. Right? That makes sense, right? If I'm concatenating two strings, I expect to get a string out. That's easy, right? I might also assert that whatever result I get out, its length is going to be equal to the two strings that I concatenated added together. Again, that makes sense, right? I might also assert that whatever I get out, it should include the first string and it should include the second string. And this is not exhaustive. This is not a complete set of every single test I could write. This is just sort of giving a flavor here. But you see what we're doing here is we're not testing specific examples. We are putting lots of data into the system and we're looking at the shape of the answers to build confidence that our system is working correctly. And we can do this with data as well. There is a library I quite like. It's called Great Expectations. Great name, very good name. And what it does is it allows us to set up these expectations for what the properties of our results are. So here's some examples here. It says, here's some data. So we run our data pipeline, and we say that all of the data that comes out, the pickup underscore date time here, the values must always be between 1 and 6. That's our property. And you can see here, it says it's found 15.79% of the results are not actually one of those expected values. So they don't have the properties that we expect. And this other one here, we say trip distance must never be null. We're not asserting that it must be a specific value. An example, we're saying it must have a certain property, which is that it's never null and that all of those answers are never null. So this is great, right? This allows us to look at the shape of the data, the shape of our results, not specific examples. This allows us to deal with the uncertainty of the Oracle problem. A while ago, I was working with Great Expectations, and I dug into the documentation. I found it really interesting, and I searched for property-based testing, right? Because this is something I've been doing for years and years and years, and I found 0 results. They don't talk about property-based testing at all. The reason for this is they call it data profiling. It's the exact same concept, but it has a different name. And I find that really interesting. See, this makes me think about pandas, not the Python library, but actual real pandas. See, the interesting thing about pandas is they have thumbs. You'll see this panda here is holding some tasty bamboo, and you'll see they're gripping it with a thumb. Now, what's interesting about this is most animals don't have thumbs. Our very close evolutionary cousins, you know, the chimpanzees, the bonobos, the great apes, they have thumbs, sure. Most animals don't, and pandas are not closely related to us. If we look at this, this phylogenetic tree, this evolutionary tree here, you can see that pandas are quite distantly related to us. So humans and mice, in evolutionary terms, we separated about 73.5 million years ago, but humans and pandas separated 85 million years ago. Mice don't have thumbs, but pandas do. So what's up with that? That's quite interesting, isn't it? Why is it that pandas are out there and just somehow they have thumbs, but no other animals do? That's really interesting. And it gets more interesting if we actually start to look at the panda's thumb. Because you see, it looks very different, right? It's not really a sticky outy thing like ours. They're actually, if you really kind of dig into it, they're not actually that great at hailing cabs because it's kind of just like a little nub. More just sort of like, yeah, sticking out there a little bit. In fact, this diagram here, it puts a thumb in quotes, like thumb, like it's not a real thumb. I think that's a little bit rude to the pandas personally, but I mean, you can kind of see where they're coming from. So pandas have thumbs, but they're very different to ours and they're completely unrelated to us. What's up with that? Because they do still have thumbs. Here they are gripping some tasty bamboo. This is an example of what we call convergent evolution. The same feature has evolved in multiple contexts separately. Because it turns out having thumbs is useful. You can use it to hold things. And this is a useful bit of functionality for your hand to have. So it evolved independently. Now it evolved in different contexts, which is why it looks very different, which is why it doesn't quite work the same, but still does ultimately the same thing. And that's what this is too. Property-based testing and data profiling is basically the same idea, but they evolved independently in different contexts. So they have different words for it. They look slightly different. They work slightly differently. And this is, I think, one of the big challenges of working in the data space, particularly if, like me, you are coming from a non-data background. You'd be moving into the sort of data engineering or data science space. You'll have to learn pretty quickly that there's actually a lot of things that you're going to be very familiar with, but they might not have the same names, or they might not look exactly the same. So this is a recurring challenge in the data space. But there are ways to solve this, as we said. There are ways to deal with the Oracle problem. It's not a magic wand that we can wave, but there are approaches that we can take to help us mitigate this, to help us work around not having a perfect test Oracle. But then we still have our second problem, right? Which is, even if we did know the answer, it would be way too big. And it's a huge pain to set up 10 gigabytes of test data. Luckily, there is a really, really simple solution to this one. Stop handcrafting test data, okay? You all right now can go to your favorite search engine and search for fake data generator. It's incredibly easy to do. So this is a nice, simple, solved problem. But if you're working with data, particularly if you're training machine learning models, the data you choose to train that model, or to test, or to validate, or evaluate that model is going to change how it works. It's going to change where its biases are. You're never going to get all of your data, all of your machine learning models perfect. They're always going to make some mistakes, right? At this point, I am legally required to quote George Box, and I'm sure several of you know this quote at this point. George Box was a British statistician talking about statistical models of the world. And he said that all models are approximations. Models are trying to describe reality, but they will never do it perfectly. The only perfect model of reality is reality itself. So all models are going to approximate things, which means all models are wrong. All models are going to get things wrong. But they can still be useful. I was reading a news website this morning, and it gave me a bunch of recommendations for articles I might find interesting. And honestly, some of them were wrong. I'm not interested in that. Thank you, but I'm not interested in that. And some of them were right. Some of them were interesting things that I actually went and read. All models are wrong, but they can still be useful to a degree. I think the question we need to ask ourselves here is, who are these models wrong for? You might have seen images like this before, looking at how different approaches to machine learning solve a problem. So on the left here, we have some inputs, right? We've got some red dots and some blue dots. And we want, ideally, what we want to do is we want to classify all of the red dots as red and all of the blue dots as blue. That's the perfect model there. And we see how different approaches, we've got decision trees, random forests, and AdaBoost, categorizing them in slightly different ways. And this is a lovely little visualization looking at how they work. And you'll see that they all get some things wrong. You'll see here, a red dot has been categorized as blue. And over here, some blue dots have been categorized as red. Those are mistakes. The models are wrong. But who do those dots represent? What is this model deciding? Is this model deciding whether or not someone is approved for a loan? Whether or not someone gets accepted in a visa program, perhaps? The problem with using fake data for testing, for validation, or even for training of models is that they're very good at catching the bell of the bell curve, the normal part, the big center part of a normal distribution. They're not very good at the tails. They're not very good at those long tails, those exceptions, those outliers. Using fake data is incredibly important, but we need to ask who it's excluding. If we exclude, who are we excluding? Are we excluding people? Does your fake data include people who don't know their date of birth? Is your fake data excluding people who don't have a fixed nationality, who don't have a fixed address? Who is your fake data excluding? Realistically, we need to use some fake, some auto-generated data as part of our work, but we do need to be very aware of how that is biasing our inputs, of how that is impacting real human beings. There are real challenges working with data and thinking about data quality and how we work around these problems. There really are, and I don't want to look away from those. But despite all of that, I still kind of think you're overthinking data quality. See, as I mentioned, I'm a QA and been working in data projects for a while, and lots of people come to me and say, Steve, we have data quality problems. Could you look at our data and help us out with this? And they show me data like this. You can look at this, right? You can see that we've got some users here, right? We've got IDs, we've got names, addresses. What type of users are they? How many orders did they make? And when did they join our platform? Okay, cool, great. And pretty quickly, we can see that there's some problems, right? I don't think AAAAA and BBBBB are real names and addresses. These are just empty strings, and these are just null values. So there's definitely something up with this data. It's definitely something isn't right. And people say, Steve, we've got quality problems. How can we fix this? And I see where they're coming from, but I don't actually agree that this is a quality problem. We are currently 27 minutes into a talk about data quality, and we haven't asked the most important question yet, which is, what is quality? I like to ask this question whenever I interview people for a QA position. I always ask this question: what is quality? How would you define quality? And I don't think that there's one perfect answer to this. I don't think there's one correct, perfect answer. There's some answers I don't like, certainly. But there is one answer I like. If you force me to give a one-line answer to what is quality, I'm going to defer to this guy. This is Jerry Weinberg. He is the patron saint of software consultants everywhere. And he said something very simple. He said, quality is meeting some person's needs. I like this, right? I like this because it's simple, it's high level. It's not about having 0 bugs. It's not about checking requirements off a list. It's about meeting someone's needs, solving their problems, making their life a little bit better. I also like it because it focuses on some person. Quality is not an abstract thing. It's not something that we can measure in a sort of Platonic Cartesian space. It is something that is relative to a person. Are we able to meet some person's need? So are there quality problems here? Well, that depends, doesn't it? It depends on the user. It depends on who's actually using this. It depends on what they're trying to accomplish here. If I'm using this data for exploratory data analysis, just trying to get a feel for what's going on in this data, what the data looks like, this could be okay. If I'm just trying to count the number of orders, like how many orders have we shipped in the last year, this might be totally fine. There's 0 problems here, right? Because these are clearly invalid, but they don't have any orders associated with them, so there's no problems. I can still count the orders here. I could maybe even tell you how many people ordered how much and see maybe even clusters of users. For particular users and particular use cases, this might be totally fine. But if I'm feeding this data into an automated system, perhaps to send out marketing or mailing recommendations, this might break those downstream systems. This could be a serious problem in that case. I would say that there are very clearly validity problems with this data, but whether or not it is a quality problem, we need to understand how this data is being used. So who is using our data? I think about it like this. We've got us, right? We've got our team, the team working on the data, training the machine learning models, building the data pipelines, populating these databases, the team actually building the things. That's us, presumably. And then we've got our user, right? The person who is getting some benefit out of this data. The person whose life hopefully is made a little bit better by our work. And very often, I'm sure many of you have a PO, a product owner, right? And they act as the representative of the customer. They are the person who maybe translates the customer's needs to what you need to do. Helps you write them as stories, perhaps. As a customer, I want a feature, so I can, One of the challenges, I think, with data in particular is we often have a lot more people in between. Maybe we've got a project management board, right? Handling all of our data projects. Maybe a data governance office. Maybe we go through various systems and various processing steps and various pipelines. Maybe this data ends up processed and ends up in a report, then it gets read by someone, or maybe it's not read by someone, or maybe they may or may not make a decision based on that data. And that the impact of that decision might take some time to actually come out before it actually has the impact on our end user, who actually has the impact on the world that we are trying to see. This is what's called intermediation. We have multiple layers of intermediaries between us and the impact we are trying to have. And this is, I think, one of the biggest challenges of working in data. I've worked on consumer applications. I have worked on applications that my friends who are not in the software industry have used. And I've been able to go to them and say, hey, how did you use my app? I added this feature last week. Did it work? That's often a lot harder to do with data because of these layers of intermediary. It's harder to see the impact, harder to see the user and the thing that this data is being used for. I think we need to try and get rid of these layers of intermediation. The word for that is to disintermediate. We remove those layers. And as much as possible, we try and talk directly to our users. This isn't always possible. Your users might be a regulatory agency. There might be legal reasons you are not allowed to talk to them. Okay, probably don't break the law. There might be multiple steps, and it might make sense that you might only be able to talk to someone a few steps away from the real impact you're having. But as much as possible, try and remove those layers of intermediation. Get as close to the impact and the users and the lives you're trying to change as much as possible. There's a manifesto I really like. It mentioned something about customer collaboration over contract negotiation. This is what it's talking about. Getting as close to your users as possible, not going through a project planning document and a review board and a data governance office and a processing plan and all of those things. Get as close to the real impact and the real users you're trying to work with as possible. And what do you do then? Once you've found your users, what do you do then? So we mentioned that ThoughtWorks, we're a global technology consultancy. We've been really published lots of books. We've been really active in the sort of growth of Agile, the DevOps movement, the continuous development of continuous delivery. And at ThoughtWorks, there's a really advanced Agile consulting technique that we use called talking to people. This is actually a real ThoughtWorks office. You can tell because almost every surface is entirely Post-it notes. Go and talk to your users. Go and find your users and talk to them. Understand how they are using your data. If you can't find your users, here's a fun little tip. Turn off your service for a week and see who sends you an angry email. That's your user, okay? That's the person who's using your data. But when you find them, go and talk to them. And there's lots of questions you can ask here. You can ask them questions like, how often is this data going to be used? Some data is used literally every second. I've worked on real-time alerting systems. The data is pulled and processed, and events are processed every single second, literally in real time. I asked this question once to a team, and they said, we use it exactly once a week, right? It could be once a week, once a day, once a month. One team said, we will use this data at exactly 9:30 a.m. on Monday mornings, because that was when they had their weekly meeting, and that was when they refreshed the dashboard. That was the only time they accessed the data. And this gave us a huge insight, because this told us that actually, you know what, we probably didn't need a streaming data system here. We probably didn't need PySpark and Kafka for this. We were actually fine with a cron job or just a scheduled job of some sort. So this actually gave the team an incredible technical insight and allowed us to act as a technical North Star. This informed our technical decisions. What do we really need to build here? Another question you can ask is, how complete does this data need to be? Some data does need to be complete, does need to be 100% complete. If you are sending a report to a regulatory agency, to an auditing body, you might have serious problems if you are missing data. FTX recently demonstrated this in an extremely funny way. Missing data can be a huge legal problem in some cases, but sometimes missing data is fine. If I'm doing a little bit of exploratory data analysis, just trying to get a feel for what the data looks like, I don't care if there's a few records missing. If I'm going to use this data to send out a one-off marketing email to a random selection of people, a bit of missing data might be fine, because I'm going to throw away most of the data anyway. There are cases when missing data is totally fine. We could also ask, how fresh does this data need to be? Some data really does need to be real time. It needs to be processed immediately as it happens. It needs to be live in the system and processed as it happens. I've worked again on real-time alerting systems, monitoring production lines. And this data was used to sound alarms. Okay, so if the sensors in the production line detect something going horribly wrong, they sound an alarm. If that alarm comes in 10 minutes late, that's actually worse than useless, because the accident has already happened and now you're just adding insult to injury. Some things really do need to be real time. And sometimes it's fine if it's just, like a week, roughly within a week. Again, if I'm doing a bit of exploratory data analysis, I don't need the freshest data in the world. It's fine. Don't worry about it. Maybe even a month old, maybe even a year old data could be totally fine for me. Then we get to the really interesting question. How accurate does your data need to be? This is interesting because everyone always says it needs to be perfectly accurate. No human being in the history of humanity has ever said, give me some inaccurate data, please. I'd love some inaccurate data. And some things do need to be really accurate. They need to be as accurate as they possibly can be. Again, regulatory, legal contexts, we probably do need the data to be pretty accurate. But I always like to ask the question, when someone says we need perfectly accurate data, I always ask the question, okay, let's imagine your data. Let's imagine I gave you this data and it was 1% inaccurate, just slightly wrong. Who dies? How many people die as a result of this inaccurate data? And they go, well, okay, well, no one's actually going to die. But okay, so I say, okay. So who loses their job, or how many millions of euro do we lose? They go, well, okay, yeah, actually, it's actually not going to happen, is it? Yeah. And sometimes we can, right? We keep asking these questions. We keep digging down till we understand what the actual impact really is. I have asked this question before, and someone says, if you get this data wrong, that person over there is going to be fired, or we are going to lose this many millions of dollars. Some data does need to be accurate, but not all data does. I'm diabetic, and I'm just going to open my my phone here. I'm diabetic, so I've got this little glucose monitor on my arm, and I can hold my phone up to it like this, and it tells me my blood sugar. So you can see here my blood sugar is currently 8.4 millimoles per liter. And you can see it's green, that's good. Now, that's medical data. I'm going to look at that data, and I'm going to make medical decisions. Should I inject insulin? Or do I need to eat some food right now? And if I make the wrong decision, I might die, which would be a really, really bad outcome for me. I try and avoid that as much as possible. So you might assume this data needs to be perfectly accurate, but it doesn't. I'm fine with this data being 5, 10, 20, maybe even 30% wrong, as long as it's representative. As long as I know roughly where my blood sugar is, I'm fine with that answer, because I'm going to take roughly the same action in any case within certain bars. So as long as it's representative, I'm fine. I'm fine with it being a few minutes out of date, even. Doesn't need to be real time. I got a really interesting insight, though, into my data quality needs earlier this year. Earlier this year, I went to Greenland on a short vacation with some friends. We did some sort of hiking out in the ice. It was very nice, lovely trip. Thank you for asking. Took all these lovely pictures, but one of the first things that happened when we got to Greenland is that we got off the plane here at Kangerlussuaq, and I went into the airport terminal, and pretty normal thing. I went to measure my blood sugar, and the app crashed. So I thought, okay, that's a bit weird. I restarted the app, tested it again, and it crashed again. Restarted my phone, and it kept crashing, and I thought, oh, that's a bit weird. Now, cursed with knowledge as I am, I downloaded I opened the developer tools on my phone, and I found the error. Give you all a second with that, see if you can see where the problem is. Oops. Just trying to get the QA chat over there. So you might have noticed this here is the problem. There was an illegal argument exception. That the time zone ID of America Nuuk, Nuuk is the capital of Greenland, for anyone who doesn't know, was not supported, was not recognized. This app did not actually support taking readings in Greenland, which was actually a huge problem for me. Because if I was going to go hiking in the ice for several days, I really need to know where my blood sugar is. I'm fine with it being a little bit inaccurate, but I do need that information, or I'm going to die, or I'm going to have serious problems. See, it turns out for this medical data, the availability of the data is much, much more important than the accuracy of the data. Turns out an error in one direction is worse than an error in another direction. If it says my blood sugar is higher than it really is, that's worse than if it says my blood sugar is lower than it actually is. These are the insights that you only get if you actually work with the users, if you actually collaborate with your users. And there's lots more questions you can ask here. Things like, how durable does this data need to be? Like, what happens if I lose some of this data after 5 years? Is that a problem? Or how consistent does this data need to be, right? How closely does it need to reflect a source system, perhaps? This might be the same thing as accuracy, or it might not. Again, you're going to have to work with your users to figure that one out. Or you might ask, how valid does the data need to be? If we're applying business rules to it, some sort of business logic, Or does it match a certain schema? This might be particularly important if I'm streaming this data into another system where invalid data might break that downstream system. There's lots of questions we can ask here. And we can use the answers to these questions, the insights we get from actually working with our users, to start to form service level objectives. Here are some examples of service level objectives. We might say that for one system, we need 99% of the records should be consistent with some source system X by 9:30 a.m. on a weekday. Or for another system, we might say 99.99% of records should be accurately processed within 1 minute of the event occurring. These are very different types of systems, and they have very different needs in terms of data quality. These are framed as service level objectives. You don't need to frame them as service level objectives, though I do find that a very helpful tool for this. If you do want to dig a little bit deeper on this topic, I recommend the book Implementing Service Level Objectives by Alex Hidalgo. I think chapter 11 in there is about data reliability and some of the things that we can look at there. I chose to go fairly light on sort of service level objective theory today. But if you do want to go a little bit deeper, I really recommend this talk by my colleague Emily Gorsensky in Germany about how to build better SLOs for data-intensive systems. You can scan that QR code if you are so inclined. I think I see Ronnie's posted that in the chat as well. Thank you. This goes a lot deeper into like how do we really structure these SLOs to get really good to actually help the team in the most effective way. So there are some real challenges working with data quality. And there are some things we can do about them. One of the big challenges is that we've got new tools and concepts to learn, particularly if, as I said, like me, you're coming from a non-data background and going to a data background, you need to learn a lot of new tools and concepts and words and frameworks. But you know what? That's always been true. When have you ever moved to a new project and everything has been the same and you didn't need to learn anything new? This is always true. And you need to deal with the Oracle problem. You need to deal with the fact that you don't necessarily know the correct answer. That's difficult. But you know what? That's always been true. The Oracle problem is one of the oldest problems in software engineering. And if you're working with data, you need to work with domain experts, people who understand the impact of our choices on data quality. Who are we excluding by choosing this as our training data and not that as our training data? You need to work with domain experts, and that's always been true. We always need to work with people who understand the domain in the best way they can. And ultimately, if we are trying to deliver quality software, quality data, quality anything, we need to understand our users' needs. And that's always been true. Thanks. That's the end.
Thank you very much, Steve. I think we have one question for now. So yes. I don't know if you already read it. Otherwise, I can do it for you, Steve.
It's okay. Let's see. Okay, I've got that there. So, is data quality not representing the quality of the application that is generating the data? So bad data means bad application itself. So kinda, yes. And that actually works in both ways, right? So let's say I've got a source system that is scanning documents into and doing optical character recognition, OCR, loading those documents into a database, and that's where my data comes from. If the OCR tool is not very good, like if it just isn't very good at recognizing that text, and that's probably going to lead to some bad data. So from the source side of things, yeah, the data that. And this is also one of the challenges that I didn't really talk about, is very often those source systems and how that data is being produced and entered into kind of our world is out of our hands, or at least not directly in our hands, let's say. So yes, and there's also another side of that, right, which is that in the book here, let me pull up Alex's book here, right? So in implementing service level objectives, Alex talks about, I'm actually not sure if Alex wrote that chapter, but in the book, they talk about, they distinguish between aspects of data reliability and the application that serves the data, right? So they distinguish between, say, completeness of the data and, say, availability of the database that is serving the data, right? So they distinguish between the data and the application, sort of quality or reliability aspects. I tend to see them as the same thing because I tend to look at it just from the perspective of the user and just say, does it matter to the user? If it does, let's just call it quality and go from there. I've been working very recently, actually for the last couple of years, on data mesh projects where we're building data products. So we're trying to think about it more holistically, so not sort of separating data from the application. So yes. I don't know if I necessarily answered your question there, but I tried. I think yes from multiple angles. Do the best I can do. I don't know if that helps.
Thank you, Steve. Rachel, let us know if this answers your question. Like if you have a follow-up, feel free to ask another one.
Yes. I'm very easy to find if you want to ask me questions. Linked, you can follow me on Twitter for the remaining 2 weeks of Twitter if you are so inclined. Otherwise, I can stop sharing the screen, and I think Matteo will throw up a lovely feedback slide because we do love feedback.
All right, just giving the chance if there is any last minute or last second question. Otherwise, yeah, I'll present the usual ending slides.
If I may, I'd be curious to know what happened in Greenland.
Oh, I never gave the ending to that story. So what I did is I had to check. Sorry, I completely left you on a cliffhanger there. I had to change the time zone of my phone to an equivalent time zone that was in Brazil. So there is only one other time zone that matches up with that, and it's on like the very edge of Brazil. So there you go, a little Greenland Brazil fact for you there. I was able to survive in Greenland. I did not die.
I had an inkling, but just an observation, if I may. A lot of the things you said about connecting to the user also apply in defining the scope of a backlog, like defining what you want to work on, not just on data clearly, but also the features, right? And people tend to forget that. So thank you for also mentioning the manifesto, this mysterious manifesto. We didn't name it.
We could share the link to that. Hang on, in case you haven't seen it yet, it is agilemanifesto.org. I assume most of you have seen that at this point. But yeah, this is why I think people are overthinking it. We go to a new world, we see all these new tools and words, but ultimately, yeah, think about your user, work closely with your user, and that's a pretty good direction, and you'll figure things out from there. So.
Couldn't agree more. Thank you, Matteo, for allowing for the last question.
My pleasure. All right, I see there are no other questions. So as anticipated by Steve, like spoiler, I'm going to briefly share just a couple of slides more. So as usual, we're going to send out a feedback form, and it would be great if you could just spare a couple of minutes to fill it up. For us, it's super important to receive this feedback so we can continue doing things that you appreciate and instead improve things that instead you dislike, so that we can keep delivering a better quality session after session. So nothing. Stay tuned to the meetup and see you next time. Thanks again, Steve, for talking, and thanks everybody for joining tonight. Have a nice evening.